All right, welcome. In this video, we're going to be learning about the chain rule, which is going to be extremely important for us in our, introductory calculus class. Okay, so I always start with the question, like, look at these functions, which do we already know how to take the derivative of? Okay, and if you look at A, that's definitely a product rule scenario. That's right in our wheelhouse. We've seen that B can be written as a product, and so we could take its derivative using the product rule. I think C, you could say, okay, I could take the derivative of that using the quotient rule. But D, this sine of x squared, this composite type of function, this is something that we don't really have anything for yet. We can't write it as a product or a quotient, and it's not a power, and it's not one of our known derivative rules, so we don't really have anything for it yet. And so this is where the chain rule is going to come in. All right, so this chain rule, this rule for how do we deal with derivatives of composite functions, it's the derivative of f of g of x equals f prime of g of x times g prime of x. And you could memorize it like that if you wanted to, but I feel like I got a better way. And just like right now, before I even get started, I want to credit where credit's due. Mr. Messner showed me this technique, and I'll admit I was a little resistant to it at first, but these days I feel like it's the only way to show people the chain rule when they don't already know it. Okay, so it's all about the outsides and the insides. So we're going to be labeling things with O and I. Okay, and to look at the way the theorem is stated, okay, on the outside of the thing we're taking the derivative of, okay, we're taking the derivative of the thing in the box. On the outside, I've got f. Okay, so I'm just going to label f as the outside, and g is the inside. Or I guess g of x is the inside. Okay, and we compute that by taking a product of two derivatives. That's super important. Okay, I'm going to be emphasizing that throughout this video. The chain rule is all about multiplying derivatives, and it's the derivative of outside prime times inside prime. And I'm actually going to just leave it right there for now, show you how it works, and hopefully this will, really scaffold your learning. And the main reason why I like this scaffold so much is it's up to you how long you use it. You take the scaffold off when you're ready. Okay, they don't leave the scaffold on the building after it's built. That's what I always say. So with this one, we need to identify our outside and our inside. And I think it's actually pretty easy. We got the parentheses, they're very helpful. So we've got sine of x squared. On the outside, I've got the sine, and on the inside, I've got the x squared. So I'm just going to write that just like that. Then I'm going to take the derivatives of outside and inside, because remember, we're going to multiply our derivatives to find the derivative of the composite function. So the derivative of outside is going to be cosine of that thing, and the derivative of inside is going to be 2x. These are derivative rules we've been familiar with for a while now. Okay, and with that, I'm going to repeat the principle here that d prime of x is going to be outside prime times inside prime. So it's set up to fill in those pieces. I'm going to have an equals and a multiplication symbol. Outside prime was cosine of a thing, multiplied by inside prime was 2x. And at this point, you're wondering, like, well, what goes inside the thing? And, well, what goes inside the parentheses is what always went inside the parentheses. So whatever goes on the inside of this cosine is what went on the inside of the sine originally, which is x squared. And that's how we do the chain rule. Now, if we go back to the statement of the theorem, we see the same concept, right? The inside stays the same. So what goes in the parentheses is still g of x, is still that inside. But I don't think it's even worth writing the I on the inside of the O prime, because that's just another thing to try to remember. And it's easier to remember, well, the thing inside the parentheses always stays the same. What else would go in there? It's just always been the same. Let me do another example for you. So we've got this y equals the square root of sine of x plus 1. And we see that square root symbol is reaching all the way over the sine of x and plus 1. So that's what's going on the outside. But when we were first learning about the power rule, we always took square roots and rewrote them as the 1/2 power. And I think that's what we want to do here. That's just my opinion. But I'm going to say on the outside, I've got after rewriting, I've got the 1/2 power being the thing that's happening on the very, very outside. And then you look at the way I rewrote the equation in black, and you can see that really makes it even more apparent that the square root is the outside of the function. Okay, now the inside is going to be sine of x plus 1. Okay, but I guess I could just take the derivative of outside first and then bring in, okay, inside is sine of x plus 1, and inside prime is going to be cosine of x plus 0. Hey, thinking back to the same idea that y prime is going to be outside prime multiplied by inside prime. Well, if I've got that, I can set up to plug in my pieces. Outside prime is going to be 1/2 of something to the negative 1/2 power, and inside prime was cosine x. Okay, and I think about what goes inside the square brackets. Well, what goes inside the square brackets is what always went inside the square brackets, or what was in them at the beginning, and that's sine of x plus 1. Just like that. Maybe I'll do another one for you. So y equals the natural log of cosine of x. Okay, we see those parentheses, we see there's layers, we know we need to use the chain rule. So we're identifying on the outside, looks like natural logs. And the derivative of natural log of a thing is 1 over that thing. And then the inside is cosine x. And I can take the derivative of cosine x, we know that's going to be negative sine x. Now I'll be thinking to myself, I want to take the derivative of y, and so I'm going to be multiplying outside prime times inside prime. So I'm going to copy in outside prime and inside prime. And thinking about what goes in those parentheses from outside prime is what went on the inside of the natural log originally, and that was cosine x. Now maybe you're looking at this thing and thinking, I feel like I can do something with that. Well, if you felt like that, maybe you should, and you could rewrite that as one fraction. That's negative sine x over cosine x, and maybe that's like, oh, I know what sine x over cosine x is. That's tangent x, so the derivative of this function is going to be negative tangent of x. All right, now before I set you loose and have you try a couple on your own, I'm going to show you one with an exponential, because these have historically been tricky for people to recognize in my class when they're first learning about the chain rule. Okay, so without getting too much into it, I just want you to think about what happens to x as it goes through its journey of going through this function and getting us y. Okay, so we start with a value of x, and then we're going to take tangent of x, right? And then we get that value of tangent x, and we put that as the exponent of e. So okay, we end up with e to the tangent x, and that's equal to y. Okay, so that's why I'm saying the exponential part of this function, that's the outside, okay, because that's happening last. And then on the inside is the tangent of x thing. Okay, but I could take the derivative of outside, especially when it's e to a thing. We know the derivative of e to a thing is e to a thing. Okay, and then on the inside, I've got tangent x, and we recently learned that the derivative of tangent x is secant squared of x. And now I'm ready to go. I'm going to take the derivative by multiplying outside prime by inside prime. Outside prime was e to the power of something. Inside prime was secant squared x. And the thing that's going to go on the inside of the parentheses is the same thing that went on the inside of the parentheses at the beginning, the exponent of e. That's going to be tangent x. All right, now here's a couple for you to try on your own. Okay, really the only way you're going to get this down is by practicing it a bunch of times. And I've got a pretty good homework set, and if you're not feeling confident after that, go look for some extra practice. Google chain rule practice. Go ask AI for chain rule practice. It'll give it to you, especially the algebraic ones, which is probably what you need. But here's two exponentials. They're pretty similar, but we'll be able to compare and contrast once you get an answer. So I think you should work these with the video paused, and then come back because I'm going to bring in the answers in about 5 seconds. All right, there we go. So on the left, okay, on the left and the right, the outside is the exponential part. Okay? Which is not to say that exponential is always the outside on the composition of functions. And maybe I'll bring in another example here in a moment where the exponential is not the outside of the composition of functions. Okay, but for both of these, the exponential is like kind of the main thing going on. And the inside is what's changing. Okay, we do our outside prime, we do our inside prime. We multiply outside prime times inside prime. We leave the inside the same, the inside of the red parentheses, and can't go wrong. So I really think that this is like the best way to do chain rule when you're first getting started. And then eventually, if you get to the point where you're looking at one and you're like, I know what the derivative of that's going to be. I can visualize what's going to happen with the O's and the I's. That's when you know you're ready to leave them behind. All right, so here you go. Here's one. So if I've got f of x equals secant of e to the x, hey, this is going to be a situation where the secant is on the outside and the e to the x is on the inside. Okay, and if we do this and we take the derivative of outside, okay, this is one we recently learned, and it might be one of the more obscure ones in your mind, but the derivative of secant of a thing is secant of that thing times tangent of that thing. And we know the derivative of e to the x is e to the x. So if I wanted to find f prime, it's going to be a product of two things, right? Two derivatives, outside prime times inside prime. So I copy in outside prime, copy in inside prime, and then I think about what's going to go inside the parentheses. What goes inside the parentheses, just like it always has been and always will be, it's always what it was at the beginning. So there we go, e to the x. Okay, so that just goes to show, e to the x isn't always the exterior, but it's a situation where we need to be able to recognize. Okay, now a different example would be like, let's look at one derivative problem two different ways. So we're going to think about cosine squared x, and we're going to find the derivative of cosine squared x using the chain rule, and we'll confirm our answer using the product rule. But I'm actually going to start with the product rule because that's what we're, probably already familiar with. So to, take the derivative of something like cosine squared x using the product rule, we need to write it as a product. So that'd be cosine x times cosine x. Okay, and then if I'm going to use the product rule, I'm just going to say, okay, well, I'm going to start off by, maybe I'll leave red the same and take the derivative of blue. And then I'll add in taking the derivative of red, leaving blue the same. Okay, and that's how the product rule works. And if I realized this is really the same thing. There's a negative sine x times a cosine x. There's two of them. So that's going to be negative 2 sine x cosine x. If I wanted to use the chain rule, I'd need to write this as with like an outside and an inside. So I think I'd, remember that cosine squared x is really where I take cosine of x and then I square the result, not squaring x, because if we were squaring x, we'd put the squared somewhere else. Okay, but with parentheses, it makes really obvious what's on the outside and on the inside. We've got the squaring on the outside, the cosine on the inside. So I take my outside prime and my inside prime, and then I'm going to multiply them, right, to get dy dx. So I'm going to take outside prime times inside prime, 2 times something to the first, multiplied by negative sine x. And what goes on the inside of the parentheses is going to be that same cosine that started off inside the parentheses, and it's going to be there, and there we see we've got pretty much the same thing, negative 2 sine x cosine x. All right, now the last thing I need to show you in this video is what to do when you have more than 2 layers of chain, because that's something we have to deal with occasionally in this class. Okay, so something like sine cubed of 2x, what if I want to take the derivative of that? Okay, well, first I'm going to rewrite the sine cubed as like a power of sine of 2x to make it the most obvious for myself. Okay, I've got the third power of sine of 2x, two ofs, that's an extra layer. Okay, so what we're going to do is identify our outside. That's the thing to the third. We're going to now have a middle, which is going to be the sine, and then we're going to have an inside, which is 2x. And we can take the derivatives of outside, middle, and inside, even if we don't totally know what we're going to do with them yet. But I suspect you have, your own conjecture about what we're going to do with these, because it works the same as outside and inside, is what I would tell you. Okay, middle prime is cosine, and inside prime is 2. Now, just like it was when it was just an O and an I, we're going to be multiplying derivatives. It's the theme of the video here. Okay, so f prime of x is going to be outside prime times middle prime times inside prime. And, okay, set that up. Okay, outside prime is going to be 3 times something to the 2 power. Middle prime is going to be cosine of a thing, and inside prime is 2. Okay, now, you might be a little worried, like, oh, how will I know what goes on the inside of these parentheses? And you already know what goes on the inside of the parentheses, what already was on the inside of the parentheses. So with blue, think about the blue parentheses. Backtrack that all the way up to m equals sine of a thing. Okay, well, what goes inside of the parentheses of cosine in the derivative is going to be what went on the inside of the parentheses on sine originally. So that's going to be 2x. And then what goes on the inside of the square brackets is what went on the inside of the square brackets originally. So that's sine of 2x. All right, so now I think this will be the good test of do you know what you're doing at this point? So this is going to be it. It's the last example for this video. G of x is log of the square root of x squared plus 1. You should try this on your own with the video paused, and then check your work against mine, and because I'm going to bring it in here in just a few seconds. But maybe even before that, I might, suggest that we identify our outside, middle, and inside and rewrite with the 1/2 power. Okay, so go for it now. All right, there you go. So hopefully you have something a little bit like that. You multiplied outside prime times middle prime times inside prime. And you get this expression, and of course, in a free response setting on the quiz or whatever, it's a safe place to stop. But if you look closely, you could simplify that down to x over x squared plus 1. So that's all I got for you for this video. Thanks for watching.